Next is motional EMF from Faraday's law. What it states that suppose we have a conductor but with its one arm moving. So let this arm be movable. So this is the field. Cross means the field is inward the plane and dot means field is coming out of the plane. So field is inward the plane means going into the plane. This arm BC is movable arm and the length of the fixed arm is L and length of the varying arm is X. Now consider a uniform magnetic field which is perpendicular to the plane of surface and U-shaped frame is placed inside the magnetic field of length L. Now flux through the surface, first to find flux is equals to B dot A where angle between them is 0. So BA where A is equals to what? Length into X. So if we have to find induced EMF, thus EMF is equals to minus d phi by dt. So phi is what? This is equals to minus d by dt of BLX where B and L is constant but X is varying. So B and L taking out to dx by dt is what? Velocity. So we get induced EMF equals to minus BLV. So this is induced EMF in term of velocity. So this is BLV. Next is motional EMF from Fleming left hand rule. Now from Fleming left hand rule, we know since a conductor BC is made up of electrons, so when the electron is moved inside, it will experience Lorentz force. And so therefore electron will start collecting at B and equal positive charge accumulate at C. B and C attain some potential difference, and due to which force acting is QVB equals to QE. Q get cancelled with QE. This is magnetic force equals to electric force because equilibrium is occurred. So we can say we get potential is equals to VBL. Potential is equals to VBL. So the current in the arm, if we have to find the current in the arm, current is equals to potential by resistance. Potential is BLV by resistance. Where if we have to calculate force on arm, force on the movable arm, so force is BIL where I is equals to this term. So we get this force. So these are expression for the current, potential difference and force. Now power dissipated to maintain motion or power dissipated in this case, power is equals to I square RT. By substituting the value of I, you get this term. This is the power dissipated. Next we have to reduce the relation between induced charge and magnetic flux. As we know, induced EMF is equals to d phi by dt where EMF is equals to what? IR. So from here I is equals to what? dq by dt. So we get dq by dt into R, that is equals to d phi by dt. So from here you can say dt get cancelled with dt, dq equals to d phi by R. dq is equals to d phi by R with a minus sign. So you get this thing. If we integrate both sides, q is equals to phi by R. Sorry. Next term is a jet plane traveling at speed of 450 meter per second. If the horizontal component of earth magnetic field is this is BH here, this is BH here, and the angle of dip is this is delta, this is delta here. So we can find the induced EMF between the end of the winds having a span of 30 meter. As B cos delta or cos theta is equals to, it's given that 4 into 10 raised to power, this is the horizontal component, 4 into 10 raised to power minus 4. So BV is equals to this term. So BE induced EMF is equals to vertical component into L into V because we have to find along this. Next is a wheel with a metallic scoops, each of 0.5 meter long, is rotated with 120 revolution per minute in a plane normal to the horizontal component of earth magnetic field. B parallel at the place is, if BH is this at a place, what is the induced EMF between the axle and the rim of the ring? Now We know BH is given, induced EMF is change in flux by time taken by substituting the value. This is change in flux is BA upon time taken T. 1 by time period is equals to what? Frequency. So we just put frequency here. We get E is equals to this by substituting old value. Since they are connected in parallel, so we remain in same, because these are connected in parallel. For the parallel, potential difference remain same. Potential difference remain same.